We were discussing about the satellite mobile services, right? And we had started off with the Asian cellular system, where we spoke about the importance of having a satellite mobile service. Now, think of a situation where the army, probably they are in a battle, okay, and they need to send information in real time, okay, without any lag, and the communication should be reliable. So in that scenario, we cannot rely on the terrestrial networks, right? So which means we need to have something more reliable. So that's when the satellite mobile services kicks in, okay? So these are more reliable, and you are always connected. Either you're somewhere strangled on a mountain, okay, or probably in the snow-capped mountains, okay. So satellite mobile services are actually playing a very important role in the field of communication, security, and connectivity. Okay, right. And there are few configurations that are involved with regards to these satellites being positioned, okay, which is about 123 degrees east, and it can have a slight variation of plus or minus about 3 degrees north and south. Okay, so as we all know, okay, once we launch the satellite, it's not immediately in orbit in its designated position, but then it will slowly maneuver, okay, and then get to its stable position in some time. Sometimes it could even take years. Okay, so this case, okay, the Asian cellular system uh, took about 3.7 years, and and it's still in service. By placing the satellite in an inclined orbit, the north-south station-keeping maneuvers may be dispensed with. So depending on where you want to place your satellite, okay, so accordingly, you will make configurations and launch with your vehicle, the launch vehicle. The savings in weight achieved by not having to carry fuel for these maneuvers allows communication payload to be increased. So if we can cut short on the weight of the satellite, okay, if we can cut short on the fuel, then probably we can increase the functionalities of the satellite. We can increase the functionalities with regards to the sensors. Okay, all those are very essential. Now, the reason why no, the amount of fuel carried can be varied is because we are very much dependent on the solar light. Okay, so once it's launched, then it can be charged using solar cells. Now again, it depends on what kind of solar cells. Is it highly dense, and the grade of solar cells? Okay, because having a good quality cell is very much essential, because the charge storage capability should be very high. Okay, this arrangement requires the use of tracking antennas at the ground station network control center. So no matter how many sensors that you employ, you need to control them with the help of antennas. And this can happen through the ground station. Okay, we can exactly pinpoint as to where the satellite is, and we can move it around. So which means there's a lot of coordination that is required with the ground station and the satellite. The population of regions serviced totals over 3.5 billion people. Okay, so that's the specialty of this satellite mobile services. It can cover wide range. Okay, we have even seen the countries, okay, that it covers, right? Similarly, there's another satellite called Garuda, which can actually have, or it's capable of having about 11,000 simultaneous calls. Okay, it's 11,000. So this can service up to 2 million subscribers, which is really a huge number. So we had seen about the spot beams, right? So it's as good as a torch light, as I mentioned in my previous lecture, where it can cover a specific portion in a geographical area. Now, why is this necessary? It's necessary in order to track things. It's necessary in order to blow up information and check, if everything's fine. Not only that, this can help us with regards to the underground. We can check the underground water table in specific areas. We can even decide on how to connect roads, how to construct bridges, which place to actually look into for further developments. So a lot of analysis can be done, okay, with this images. In fact, we are using it day to day, and we can see that how our lives are getting embedded with the use of these maps, right? Most of the time we don't tend to remember things, but then we fully rely on the maps, and we go about trusting the navigation. Subscribers are provided with a dual mode phone that can be switched between uh, satellite and GSM modes of operation. So that's the specialty. Okay, so you can either switch to a terrestrial network, or you can either switch to a satellite network. So your phones should be specially built. The circuit should be able to switch between two things and able to recognize as to how things can work out wherever you get the proper signal. That's what I was talking to you about the handoff. So handoff is basically done when your cell is full, or probably you do not have proper service. Okay, if there are more number of users, in order to maintain the quality, you will be handed off to another cell. Okay, so we had spoken about the frequencies involved as well, right? The C band, which is extensively used, and the uplink ranges, which are about 6.4 to 6.7. So we can average it out to 6.5. Um, and here we also use the L band, okay, for the mobile links, which is about 1625 to 1660. So I can say 1.6 to 1.625 to 1.660 gigahertz, right? So that's the range. And the gateways are normally the junctions where the telephone, just like your routing stations, okay, where the calls gets routed from one point to another point. The second satellite will be employed to expand the service into Western and Central Asia, Europe, and Northern Africa. So not only this is sufficient, but we also employ a few more satellites in order to have a wider footprint. So there was a satellite called Turaya. Okay, sometimes it can be asked in your examinations to write a brief note about these satellites, and you may have to remember its angle of inclination when it was done, and what is the region that it's serving, and what are its specifications. Okay. This satellite has a geosynchronous the system is geosynchronous, okay, which means we feel that it is stationary, but then it's actually in sync with the movement of the Earth, the rotation of the Earth, and it's located. Okay, so its signature is 44 degrees and 28.5 degrees east longitude. As you all know, we have these imaginary lines, which are the latitudes and longitudes. So accordingly, these are mapped, just like how we say a specific address, and there's no other address with the same pin code. So similarly here, we will find that this is its uh, address in the space, and it has an inclination of about 6.3 degrees. So again, we can move this with respect to north south, and this happens with the station keeping maneuvers, which means we can control it with the base station that's available here um, on Earth. The first Turaya satellite was launched in 2000. That was on October 21st. And right after 3 years, they were able to launch another one. So the third satellite is being built to increase the system capacity. So as we increase the number of satellites, the footprints does increase and the spot beams also can be enhanced. The capabilities, if in case they were not able to do fine with the previous version, then they can always manage to, do well in the second version and the third version. So basically what happens is, with the type of batteries involved, with the type of technologies, with the type of sensors, their capabilities, the distances that it can range from, the type of antennas, okay, all these actually play a very important role. Not only a single satellite, but in this case, since three satellites were launched, just if in case the first one goes off, we would be able to manage the second and the third one. Remember, we were talking about the communication systems, right? Where we have a backup amplifier and many other things. Because just because if one amplifier doesn't work, then we cannot go and get these things rectified. Of course, in future, uh, your job perspectives might change. They might hire. In future, it could happen. Okay, your job profile might be in space. Okay, it may not be here on Earth, where they might say that your job profile uh, is to go to a particular satellite and get the circuitries fixed and get back. So this could also happen in the future. Why not? Right? Okay. The Turaya satellite system serves an area between about 20 degrees west to 100 degrees east longitude and 60 degrees north to 2 degrees south latitude. So this is with respect to west, east, north, and south. Okay. So this can cover about 110 countries with a combined population of 2.3 billion. Can you imagine? The previous one, okay, was able to cover just a few million, right? You can just see here, okay, it was able to serve uh, the previous satellites. The different satellites were able to serve only about 2 million subscribers. But here now the range is actually increased, right? So they can serve up to 2.3 billion of population. So the footprint, the countries that it covers are Europe, the Northern and Central Africa, and many of Southern African regions. Okay. So not only this, we need to have an antenna which is huge and that can provide spot beams with onboard beam switching. So which means I can have one beam at one country and probably I can switch the beam to another country. So this is possible only when you have greater sensors. The circuitry should work fast. Ultimately, there's a lot of enhancements that has been done with the field of electronics, in the field of transistors, the way the source gate and drains are placed, the way they are, spaced apart, the type of technology. It could be MOSFETs from BJTs to MOSFETs. It can be FinFETs. Okay, so all these will actually uh, involve in getting a better, reliable system. An uplink beacon signal provides beam adjustment to compensate for non-geostationary path of satellites. See, there's a major upgrade happening to the spot beams. Not only they can just have a spot beam, but also you have the capability of adjusting them and making them more precise for the area that is needed, right? So that's a huge breakthrough that scientists were able to employ, with regards to satellites. The system operates with a 10 dB fade margin to allow for shadowing of handheld units. So it should be even able to cope up with the losses that can happen. Now, as you have seen, many losses, right? Many types of losses. It can be EIRP, it can be your atmospheric loss, right? So we have seen extensively about losses. So these satellites should be able to compensate for the losses that would happen. The network capacity is about 13750 telephone channels. Okay. So our terrestrial networks probably wouldn't be uh, even close to this number. Okay. Quaternary phase shift keying modulation is used with FDMA. So multiple types of uh, your analysis is done. Okay, multiple types of modulations are done. Okay, one can be your FDMA and the other can be your TDMA. As you all know, can someone tell me what is the difference between FDMA and TDMA? You have studied this extensively in your uh, wireless communication lab as well as in your theory. So what's the difference between FDMA and TDMA? Can someone unmute and respond? Saimanti, I think you can answer that. Santosh, Shweta, Shweta S. Anybody wants to take it? Very simple question, isn't it? Pawan. Okay. So we are looking at the modulation with respect to frequencies, and here it happens with respect to time slots. Okay, so time slots and the frequencies. Of course, both are different, and they have their own pros and cons. Dual mode handsets are used that can be switched between GSM mode and satellite mode. So which means the phones should be capable of switching between the lower frequencies that are used for the terrestrial networks and the much higher frequency ranges that are employed in the satellite communication. Service features include voice telephony, fax, data, then your SMS service, location determination, emergency services, and high power alerting. So if in case there's usage of high power, then of course it can alert because it's all battery enabled, right? So which means there should be a mechanism which can check and alert the user to take precautionary measures. So not only about alerting the high power usage, but it can also be used for voice, fax, the data services, okay, and locations, right? You will be able to share your locations, and not only that, you can even contact the emergency services, like how we have in our country, right? The mobile links operate at frequencies in the L band, okay, then also the gateway frequencies in the C band. So you can imagine the higher frequency ranges that are involved. So One thing you should keep in mind is your P is equal to V into I. Okay, P is equal to V into I cos theta, right? So it is very much dependent on the voltages, the currents. Okay, power is very much dependent, and not only that, if you can see, it's also dependent on the frequency. You have another formula for power, right, which talks about the frequency of operation. So if the higher frequencies are employed, then the power utilized will also be high. So which means we should be able to you know tackle that, and we should be able to counterattack the power drain that happens due to the extensive use of higher frequency range. The next one that we can discuss is about MSAT. Okay. So this is a short form which is used for uh, mobile satellites. Yeah, MSAT. So the system has two geostationary satellites. They launched one and two, and these also do provide access to North and Central America, Northern and Southern America, the Caribbean. Caribbean means Trinidad and Tobago, right? And then Hawaii, sorry, and in coastal waters. Okay. So basically, this is targeting the Americas. The system is operated by uh, MSV, Mobile Satellite Ventures, which has offices in in Canada, then in different other places. Okay, right. A variety of services are offered. Okay, just like the previous one, uh, which gives uh, tracking and managing trucking fleets. So uh, wireless phone, data, fax, radio services, and GPS. Right, all these are necessary when you have a phone, and the frequency of operation is also the same, which is about in the L band and C band. One thing to be understood is as the number of satellites to increase, the capabilities, the specifications also does increase. So which means those which you were not able to with your previous satellites, you will be able to try to compensate that with the upcoming satellites. So those things will be kept in mind, and it will be designed accordingly. The feeder links to the ground segment, which connects with public and private telephone and data networks, are in the KU band. Okay. So ground segment, which means your ground station offices do work with the KU band frequency. The downlink is about 10.75 to 10.95, and the uplink is about 13. Okay, so as I've always mentioned, your downlink frequencies would be much lesser compared to your uplink frequency. The two transponders are used for the KU band and L band forward link, and one transponder is used for the L band, KU band return link. So the use of transponders, how they can down convert, how they can up convert, the amplifiers, modulators, demodulators play a very important role when we are dealing with different frequencies, which can deal with downlink and uplink. Then the power will be about 600 watts, which is actually huge. But thinking of the communication that happens, many kilometers far, is something to think about. Two L-band mesh reflector antennas, which is about 5.7, I can say 6 by 5 meters, are used to give an EIRP of 57.3 dB watts. Okay. Then the power output for KU band is about 110 watts. So only if you think of KU band, then it is 110. If you think of the L band, it's 600 Mets. Satellite operation and maintenance is carried out by Telesat Canada. Okay, so they are one of the major service providers who takes care of most of the satellites, the launches, and their maintenance. The next concept that we'll be looking into is VSAT. Okay. So VSAT is nothing but very small aperture terminal system. This is the figure that you can actually check out, where the satellite actually broadcasts the information to remote sites. Okay, so you can take this outdoor unit as an example, and from here it gets into an indoor unit and then to your television. So that is one part. The other one can be, it can be to hub. Okay, and then from there you can connect it to your computer. So we were discussing about the concepts where the interconnection concepts, where various communication links can be routed through the hub. Okay. So all these telephone channels and all this will be maintained. So that can act as your gateway terminals. Okay, the gateway terminals. Right. So now that you have understood as to how information, in fact, you can see there are red dots and blue dots. Okay, so red dots is for sending information, which is the uplink, and blue dots is for receiving information. So you can see the red dots here in this fashion, and you can see the blue dots, which means it is receiving information from the satellite. So it can be either to a hub equipment, or probably it can be to smaller sites. This can be with regards to the televisions. So some of the features that we need to think about with respect to VSATs are: the Earth station antennas are less than 2.4 meters in diameter, and the trend is towards even smaller dishes. So we are able to make these dishes even smaller, but of high capacity. Okay, that's what the innovations are happening these days, because we do not want to have a bulky outdoor unit. Instead, we want to have a minute unit which can actually work out as good as a bigger unit. VSAT is usually reserved for private networks. So if you want to have a private network, then VSAT can obviously be used. So that's why we use the concept called VPN, which is virtual private network, right? So which can support with the help of VSATs. It mostly provides two-way communication facilities. As I told you, it can send as well as receive. So we are interested in this kind of information, where in this kind of dual capable antennas which can transmit and receive. Not only just transmit and not only just receive, but we want both to happen so that it can be controlled. Okay. Typical user groups include banking and financial institutions, airline and hotel booking agencies, and large retail stores with geographically dispersed outlets. So this can be specifically used for different purposes. So if you want a private network, if you do not want your network to be disturbed with the number of users from the other providers, then probably you can have your own virtual private network, your own private network, so to say, and you can host your websites wherein there wouldn't be any kind of interruptions. Okay, so if you can just imagine the air ticket booking, it's all dependent on the type of gateway they use, how the banking system works, and automatically the system should be able to allocate a seat, and once it's allocated, then that seat should be booked, which means it should be locked. Person B, if example person A has booked, then the same seat shouldn't be available to person B. So all these, there are a lot of algorithms, there are a lot of calculations, there are a lot of pricing strategies that needs to be applied with regards to booking agencies and many other things. Okay, so if you can think of the banking institutions, okay, they need these days, you have all these currencies, the digital currencies which have come into market. So keeping all those secure is very much important. Okay. So these days, as you can see, there is a lot of cyber crime that happens, right? So if you are not careful, then you might fall prey to all these frauds that can happen online. Okay, fine. So there are a few more points about VSAT. Uh, we will we will just look into it. So the basic structure of VSAT consists of a hub station which provides the broadcast facility. Not only broadcast, but then, as I mentioned, they should be able to communicate or send, receive a lot of information, right? So only then we can call it to be of more reliable. So as you can see in the diagram here, okay, you have the sending of information, and then you have the receiving of information, and indoor units, user terminal. So it could be anything. It could be your computer, or probably it can be your television, or anything for that matter. So it consists of a hub station which provides a broadcast facility to all the VSATs in the network. The hub station is operated by a service provider, and it may be shared among number of users. Each user organization has exclusive access to its own VSAT network. Okay. So even though there can be a service provider, he can provide a customized service for each user as a private network. Okay. So that's the importance of having a VSAT, very small aperture terminal. Time division multiplexing is the normal downlink mode for transmission from hub to the VSATs. Okay. So we use TDMA for transmission from one hub to another hub. So which means from this hub to the VSAT, okay, to these, we actually use TDMA. Okay. And the transmission can be broadcast for reception by all VSATs in the network or address coding. This can be used to direct messages to the selected VSATs. So this hub will actually decide to whom to send the information, and accordingly it is directed personally. So that's why we call it as a private network. So all that happens with the help of, or using the technology of time division multiplexing, where each uh, time slots are given for the purpose of communication. So I think we'll end our lecture here, and probably we will look into few more details about VSATs, and the other things, the shortcomings, the advantages, and probably the other configurations of satellites in our upcoming classes. Any questions, students? Any doubts? You can feel free to ask me. Any doubts? Okay, fine then. So we will all meet in our next lecture.